What if I tell you that past, present and future might all exist simultaneously? Well, that's what the recent scientific discoveries seem to be revealing. Let's learn more.
Time, in its most basic form, is a continuous sequence of events that we perceive as past, present and future. But physics provides us with a different perspective. Here, time is considered the fourth dimension, complementing the three dimensions of space. In the early 20th century, a game-changing theory emerged that forever altered our understanding of time. In 1905, Albert Einstein introduced the world to his special theory of relativity. This theory proposes that space and time are not separate entities, but are interwoven into a four-dimensional fabric known as space-time. And now let's dive a bit deeper. Space-time isn't a rigid structure. Picture a heavy ball placed on a stretched rubber sheet. The ball would cause the sheet to sag, right? Similarly, space-time bends around massive objects like stars and planets. This curvature of space-time is what we perceive as gravity. But here's where things get really fascinating. This curvature of space-time also affects time itself. The closer an object is to a massive body, the slower time seems to pass for it, a phenomenon known as time dilation. So if you were to stand on the surface of a neutron star, your wristwatch would tick much slower than that of your friend back on Earth. Are you still with me? Good, because this is where we start to challenge our linear perception of time. If time can be bent, stretched and slowed, then it's not as straightforward as we think. This leads us to the theory of the block universe, a concept that suggests the past, present and future might indeed coexist. So, in the realm of physics, our linear perception of time may not hold up. That's where the theory of block universe comes into play. The block universe theory, also known as eternalism, paints a fascinating picture of our universe. This theory, which has its roots in the field of special relativity, proposes a model of the cosmos where past, present and future coexist. It's a theory that challenges our everyday perception of time as a flowing river. Instead, it presents us with a four-dimensional block. In this block, time is just another dimension, akin to the three spatial dimensions we're familiar with. It's an idea that shakes up our understanding of existence, suggesting that every event, every moment is etched into this cosmic block. From the birth of the universe to its eventual demise, all are set and unchangeable. Now, this might sound like a science fiction story, but there's data to back it up. The time dilation effects observed in GPS satellites, for instance, are a testament to the flexibility of time. These satellites move at high speeds relative to the surface of the Earth, and as a result, their internal clocks tick slower than ours. This, in essence, is a real-life example of time as a malleable dimension, just as the block universe theory suggests. The block universe theory also provides a new perspective on free will. If everything is already set in this cosmic block, does free will exist? Or are we merely following a predetermined path? There's a lot to unpack in the block universe theory, and it's a topic that continues to inspire debate among physicists and philosophers alike. It's a theory that, while challenging, offers a unique and captivating view of our universe. From the data we've gathered and the observations we've made, it seems that time isn't as straightforward as we once thought. In the block universe, every event that has happened, is happening, or will happen, is always there. However, the quantum world seems to tell a different story. You see, quantum mechanics introduces a concept known as superposition, which is a far cry from the deterministic nature of the block universe theory. Superposition is the mind-bending idea that a particle can exist in all its possible states at once. It's only when we measure it that the particle is forced to choose one state. This is a stark contrast to the block universe theory, where the past, present and future are all laid out like a static block with no room for change. To illustrate this, let's take a look at the famous Schrödinger's cat thought experiment. In this scenario, a cat is placed in a box with a radioactive atom that has a 50-50 chance of decaying and killing the cat. According to quantum mechanics, until we open the box to check, the cat is both dead and alive at the same time. It's in a superposition of states. Only when we observe does the cat choose to be either dead or alive. Now, this may sound like a morbid fairy tale, but it's a cornerstone of quantum theory, and it's backed up by a wealth of experiments. Quantum experiments routinely show this probabilistic nature of the quantum world. where particles exist in multiple states until observed. For instance, in the double-slit experiment, particles can go through two slits at the same time, creating an interference pattern on a screen behind the slits. This demonstrates that until we measure the path of the particles, they exist in a superposition of going through both slits. These experiments suggest a world far removed from the fixed future of the block universe theory. Instead, they present a picture where the future is not predetermined but is full of probabilities and potentialities. So in the quantum realm, the future is not set in stone, it's a realm of possibilities. Clearly, there's a contradiction between the deterministic block universe and the probabilistic quantum mechanics. The block universe theory perceives time as a solid, unchanging structure where past, present, and future are all equally real. On the other hand, quantum mechanics posits that reality is inherently uncertain until observed, suggesting a changing, dynamic universe. This creates a paradox that has puzzled scientists for decades. Now let's delve into the ongoing debate and challenges in reconciling these two perspectives. Some scientists argue that the deterministic nature of the block universe theory contradicts the inherent uncertainty of quantum mechanics. Others believe that these theories are two sides of the same coin, and that they describe the same universe from different perspectives. There have been various attempts to unify these theories. One of the most prominent is string theory. This theory proposes that the fundamental constituents of reality are one-dimensional strings rather than point-like particles. It also predicts the existence of more than 4 dimensions, which could potentially accommodate both the block universe and quantum mechanics. Another attempt is quantum gravity, a theoretical framework that seeks to reconcile the principles of quantum mechanics with those of general relativity. This theory proposes that space and time are not continuous, but are composed of tiny, discrete units. This could potentially resolve the paradox between the block universe and quantum mechanics. However, these theories are not without their challenges. The mathematical models supporting these theories are complex and highly abstract, making them difficult to test empirically. Despite this, these theories have provided valuable insights into the nature of time and reality. The data supporting these theories is also intriguing. For instance, string theory is supported by mathematical consistency, while quantum gravity is supported by experimental data from high-energy physics. So the question remains, do past, present, and future all exist simultaneously? The answer, it seems, is not so straightforward. As we continue to explore the mysteries of the universe, we can only hope that we will one day have a clearer understanding of the true nature of time. The realm of physics is full of paradoxes and mysteries, and the concept of time is no different. We've embarked on a journey through the intricate tapestry of time, from the expansive block universe theory, suggesting that the past, present, and future coexist, to the quantum mechanics perspective, arguing for a more dynamic, evolving universe. The block universe theory paints a picture of a timeless world where every event, from the dawn of the universe to its eventual end, exists simultaneously. On the other hand, quantum mechanics, with its wave function, collapse, and quantum superposition, proposes that the future is not set in stone and can branch out into a multitude of paths. These are two contrasting views, both compelling and complex in their own right. Theoretical contradictions and challenges abound, making the journey to understanding time a fascinating one. As we delve deeper into the mysteries of the universe, one thing is clear: our understanding of time is bound to evolve. And who knows, we might just find that the past, present, and future are indeed intertwined in ways we can't even begin to fathom.